The first problem is, how many numbers between 15 and 500 are divisible by 5? Now, when we say divisible by 5, you can divide a number by 5 without any remainder. Now, take note of the given conditions. The numbers are between 15 and 500, and they should be divisible by 5. So let the common difference be equal to 5. Then our first term is 20. It is not 15 because 15 is excluded. Then 20 is the first number that is divisible by 5 after 15. Then our nth term here is equal to 495. This is the last number before 500 that is divisible by 5. Then we are looking for the value of n. Now, since we have a common difference, we are going to use the concept of arithmetic sequence in solving the problem. To solve for the value of n, we are going to use the formula for the nth term. And that is t sub n is equal to t sub 1 plus the quantity of n minus 1 times d. Now, let us substitute the given value. So, our t sub n is 495 equals to t sub 1, which is 20, plus our n is unknown, so n minus 1 times 5. Now, follow the order of operations in simplifying the equation. So, we are going to multiply n minus 1 and 5 first. So, copy 495 equals 20. And then let us multiply. N times 5 is positive 5n. The negative 1 times 5 is negative 5. Then you are going to combine like terms. So since our unknown is contained in the term 5n, we are going to transpose 5n to the left side of the equation. So since 5n here is positive, it will become negative 5n after we transpose it. Then copy 20, copy negative 5, and then you are going to transpose also 495 to the other side of the equation. So since it is positive on the left side, it will become negative on the right side. Then we are going to simplify. Copy negative 5n, then add 20 or combine 20 minus 5 minus 495. So that is equal to negative 480. Then we are going to divide both sides by negative 5 because the only variable that should be left on the left side is n. That is why we need to divide both sides by negative 5. So negative 5n over negative 5 is equal to negative 480 over negative 5. So negative 5 divided by negative 5 is 1. Copy n, and then negative 480 divided by negative 5 is equal to 96. That means there are 96 numbers between 15 and 500 that are multiples of 5, or they are divisible by 5. Okay, so our second example is to determine how many numbers from 9 to 81 are divisible by 3. Now take note of the given conditions. The numbers are from 9 to 81 and they should be divisible by 3. So let us determine the given values. Let the common difference be equal to 3. Our first term is 9 and the nth term is 81, and then we are looking for the value of n. Now, why is it that the given extremes are the first term and the nth term? It is because of the word from. Now, what is the difference when you have between and from? When we say between, the given extremes are excluded. That means they are not part of your sequence. But when you have from, that means the given extremes are included or they are part of your sequence. Now let us solve the given problem. Using the nth term for an arithmetic sequence, we can solve for the value of n. So t sub n is equal to t sub 1 plus n minus 1 times d. Substitute the given values. We have 81 equals 9 plus n minus 1 times 3. Combine, or we are going to perform first multiplication. So that means we need to copy 81 equals 9. Then multiply n and 3. So we have 3n. The negative 1 times 3 is negative 3. Now combine like terms. That means we need to transpose positive 3n to the left side of the equation. Because we always write the unknown in the left side of the equation. So since it is positive on the right side, it will become negative on the left side. Then copy 9 minus 3. So positive 81 here will become negative 81. Then we have negative 3n equals 9 minus 3 minus 81 is equal to negative 75. So negative 3n is equal to negative 75. Now we need to divide both sides of the equation by negative 3 so that the only variable left on the left side is n. Negative 3n divided by negative 3 is n, and then negative 75 divided by negative 3 is positive 25. That means there are 25 numbers from 9 to 81 that are multiples of 3 or are divisible by 3. Okay, so the next example is to convert 0.3 to fraction form. Now, can you see the bar above the digit 3? It means the digit 3 is repeated infinitely. So, since 0.3 is equal to 0.333 and so on, and 0.333 and so on is equal to 0.3 plus 0.03 plus 0.003 plus so on. Take note, this one is an infinite geometric series. Series because you are adding the terms, and infinite because of the ellipses. Now let us identify the given are the given values. So we have t sub 1, which is equal to 0.3. T sub 2 is equal to 0.03. By the way, 0.3 is equal to 3 over 10. And 0.03 is equal to 3 over 100. Now let us determine the common ratio. So R is equal to t sub 2 divided by t sub 1. So we can solve using the fractions or using the decimals. So let us solve using the decimals because I have a limited space here. So R is equal to 0.03 divided by 0.3. This one is equal to 0.1, or let us convert this one into a fraction, so 1 over 10. So to solve or to convert the decimal to fraction form, let us use the formula for the infinite geometric series, and that is S sub infinity is equal to t sub 1 over 1 minus r. So S sub infinity, substitute the given values. So t sub 1 is 3 over 10 over 1 minus 1 over 10. So S sub infinity, you are going to perform first the operation in the denominator. So 3 over 10 is equal to 1 minus 1 over 10 is 9 over 10. If you can still remember the shortcut that I had given you last week, if you are going to subtract a fraction from 1, just subtract the denominator and the numerator and copy your denominator. So 10 minus 1 is 9, then copy 10. And then let us divide. Now, to divide fractions, you need to get the reciprocal of the denominator and multiply it to your numerator. So S sub infinity, I am just going to write here, S sub infinity is equal to 3 over 10 times the reciprocal of 9 over 10 is 10 over 9. So since we have 10 here in the denominator and 10 as numerator in the other fraction, so we are going to cancel. So 3 over 10 times 10 over 9 is equal to 3 over 9, or the lowest term of 3 over 9 is 1/3. So 0.333 and so on is equal to 1/3. Now let us proceed to the next example. Convert 0.21 to fraction form. As you can see, the bar here is above the digits 2 and 1. That means the digits 2 and 1 are repeated infinitely. So 0.21 with a bar above is equal to 0.2121 and so on. And 0.2121 and so on is equal to 0.21 plus 0.0021 plus so on. So again, this is an infinite geometric series. Now let us identify the values. So t sub 1 is equal to 0.21 or 21 over 100 because we have two decimal places. And our t sub 2 here is Okay, it's 0.0021 or 21 over 10,000 because we have 4 decimal places. And then let us solve for the common ratio. So R is equal to 21 over 10,000 divided by 21 over 100. So the common ratio now is 1 over 100. Now the shortcut for this, without dividing the second term by the first term, is you just make 1 as your numerator, and then your denominator will depend on the number of digits that are being repeated. So for example, in example number 3, we only have 1 digit that is being repeated. So in our denominator, we have 1, 0 after 1. And in our second example, in converting a non-terminating repeating decimal to a fraction form, we have 2 digits that are repeating. So that means our denominator here is 100 because we have 2 digits. That means we have 2 zeros after 1. Now let us solve now. So S sub infinity is equal to T sub 1 over 1 minus R. Substitute the given value. So S sub infinity is equal to 21 over 100 divided by 1 minus 1 over 100. So S sub infinity is equal to 21 over 100 divided by 99 over 100. So S sub infinity. Now I have another shortcut for you. When you are dividing fractions and they have the same denominators, you just cancel the denominators. Again, this one is another shortcut. If you are dividing fractions that have the same denominators, just cancel their denominators. So we are going to remove 100, and then we now have 21 over 99. So the lowest term of 21 over 99 is 7 over 33. That means the decimal 0.21 is equal to 7 over 33. Now let us proceed to another example. As you can see, I like giving shortcuts to my students because it will make their life easier, life in mathematics easier. The next problem is a sari-sari store sells 2,000 pesos worth of products during its first week. The owner of the sari-sari store has set the goal of increasing her weekly sales by 250 pesos a week for the next 9 weeks. If we assume that this goal is met, find the total sales during the first 10 weeks. Now let us identify the given values of the problem. So we have the first term, which is 2,000, and then 250 is our common difference. Our n here is 10. It is not 9. It is 10 because our problem is to find the total sales during the first 10 weeks. And then we are looking for the sum of the first 10 terms. Sum because total sales. Now we have different ways to determine the sum of the first 10 terms. Now this is solution number 1. By using this formula, so S sub n is equal to n over 2 times 2 t sub 1 plus quantity of n minus 1 times t. Now substitute the given values. So we have S sub 10 is equal to 10 over 2 times 2 times 2000 plus 10 minus 1 times 250. Now this is very long. Now let us simplify the equation. So we have S sub 10 is equal to 10 over 2 is 5 times 2 times 2000 is 4000 plus 10 minus 1 is 9 times 250. Now we have S over 10 is equal to 5 times 4000 plus 9 times 250 is equal to 2250. And then we need to add. So S sub 10 is equal to 5 times 4,000 plus 2,250 is 6,250. Now S sub 10 is equal to 5 times 6,250 is 31,250. That means the total sales during the first 10 weeks is 31,250 pesos. Now let us go to another solution. The second solution is to determine first the total sales, or the sales rather, during the 10th week, and then by using another formula for the arithmetic series. So let us determine first the 10th term. So that would be t sub n is equal to t sub 1 plus n minus 1 times d. So t sub 10 is equal to 2000 plus 10 minus 1 times 250. So t sub 10 is equal to 2000 plus 9 times 250. So t sub 10 is equal to 2000 plus 2250. So the sales in the 10th week, or during the 10th week, is 4,250. Now let us get the sum of the first 10 terms, or the sales during the first 10 weeks. So we have S sub n is equal to n over 2 times t sub 1 plus t sub n. Substitute the value. So S sub 10 is equal to 10 over 2 times 2000 plus 4250. So S sub 10 is equal to 10 over 2, which is 5, times 4250. So S sub 10 is, it is 6250. So S sub 10 is 31,250. That means the total sales during the first 10 weeks is 31,250 pesos. Okay, what about if we are having a hard time in using the formula? We can solve this problem using a table. So let us solve the problem using a table. So we have here week and then sales. So first week we have 2,000. For the second week, the total sales is 2,000 plus 250 is 2,250. Third week is 2,500. Fourth week is 2,750. Fifth week is 3,000. Sixth is 3,250. Then on the seventh week is 3,500. Then for the eighth week we have 3,750. Ninth week is 4,000, and then for the 10th week is 4,250. Then we are going to add them. So since I have a limited space in writing, I will just write it this way. So S sub 10 is equal to 2,000 plus 2,250 plus up to 4,250. So it means I am going to add 2,000, 2,250, 2,500, 2,750, 3,000, 3,250, 3,500, 3,750, 4,000, and 4,250. So after adding, I will have 31,250. That means the sales during the first 10 weeks is 31,250 pesos. Now, let us go to the next problem. Mr. Thor Odinson accepts a teaching job or teaching position in a private school and will receive a salary of 180,000 pesos on the first year. He is guaranteed a raise of 1,200 pesos per year for the first 5 years. How much will he receive on the 6th year if he is given the same raise? Okay, now, so our first term here is $180,000. The common difference is 1,200, while n is equal to 5. It is equal to 6. Sorry, it is equal to 6 because we are looking for the salary that he will receive on the 6th year, and then we are looking for T sub 6. T sub 6 because we are not asked of the total salary that he will receive during the first 6 years, but we are asked for the salary that he will receive on the 6th year. Now, since this is an arithmetic sequence, we are going to use the formula T sub n is equal to T sub 1 plus n minus 1 times T. Let us substitute the given value. So we have T sub 6 is equal to 180,000 plus minus 1 times 1,200. So T sub 6 is equal to 180,000 plus 6 minus 1 is 5 times 1,200. So T sub 6 here is 180,000 plus 5 times 1,200 is 6,000. So let us add. So we have now 186,000. That means Mr. Thor Odinson will receive 186,000 on the 6th year. Okay, so this is the first solution to this problem. The second solution is by using a table. If you don't know, or if you are not sure of the value of n, you can use a table. So we have here year. The year is the position of the term, and then the salary. So for the first year, Thor will receive 180,000. For the second year, since he will be given a raise of 1,200, so he will receive 181,200. For the third year, given another raise, so he will receive 182,400. For the fourth year, he will receive 183,600. For the fifth year, he will receive 184,800. And for the sixth year, he will receive 186,000. So Mr. Thor Odinson will receive 186,000 pesos on the 6th year. Now let us proceed to the next example. Okay, so the next problem is, suppose a ball is dropped from a height of 24 feet and it bounces up to 75% of its previous height after each bounce. So this one involves a geometric sequence. Take note, we have here 75% of its previous height. Now let us solve first. For the first problem or question, if h sub n is the greatest height of the ball after the nth bounce, find h sub n. Now, when we say h sub n, that is equal to p sub n. So let us identify first the given values. Our common ratio here is 0.75 or 75%. 75% is equal to 0.75. And then, our first term is not 24. Our first term is the height, the greatest height of the ball after the first bounce. So, we still need to compute. So, 24 times 0.75 is equal to 18. Or this one is h sub 1. Now let us determine h sub n using the formula for the nth term of a geometric sequence. So we have h sub n is equal to h sub 1 times r raised to n minus 1. Substitute the given value, so we have h sub n is equal to 18 times 0.75 raised to n minus 1. So this is the general term of the sequence, or the greatest height of the ball after the nth bounce. Now let us go to the height of the ball after the 8th bounce. So our n here for letter B is 8. So we have now, again using the formula, so our general term is h sub n is equal to 18 times 0.75 raised to n minus 1. Now substitute n. So we have h sub 7 is equal to 18 times 0.75, which is raised to, so I'm sorry, it is h sub 7, h sub 8. So 8 minus 1, so h sub 8 is equal to 18 times 0.75 raised to 7. Now 18 times 0.75 raised to 7 is equal to 2.4270961, or approximately equal to 2.4 feet. That means the height of the ball, the greatest height of the ball after the 8th bounce is approximately 2.4 feet. Why is it approximately? Because we already rounded off the answer. Okay, now let us proceed to the last problem. Suppose Tony Stark saves 1,000 pesos in January, and that each month thereafter he manages to save 1/2 more than of what he saved the previous month. How much is Tony's savings after 10 months? So let us identify the given value. So our T sub 1, or the first term, is the amount that he saved in January. So that is equal to 1,000. And then our common ratio here is 1.5. Why 1.5? Remember this, 1/2 more than of what he saved. So 1/2 is 50%, or 0.5, and then more than of what he saved, that means 100% of what he saved the previous month. So that is 100% plus 50%, which is equal to 150%, or 1.5. Now, how much is Tony's savings after 10 months? So our n here is equal to 10. Now, this is not an arithmetic sequence because we have here a ratio and not a difference. Be careful in identifying the given value. So, we are looking here for the what? Is it the 10th term or the sum of the first 10 terms? Okay, very good. It is the sum of the first 10 terms, because you are going to add Tony's savings from January up to October. So let us solve now. So we have S sub n is equal to T sub 1 times 1 minus r raised to n over 1 minus r. So this one is S sub n, I'm sorry. Then S sub 10 is equal to 1,000 times 1 minus 1.5 raised to 10 over 1 minus 1.5. So S sub 10 is equal to 1,000 times 1 minus 1.5 raised to 10 is approximately 57.67 over 1 minus 1.5 is negative 0.5. Take note, I did not use the equal sign but the approximately equal to sign because I already rounded off the answer of 1.5 raised to 10. And then let us simplify. So S sub 10 is approximately equal to 1,000 times 1 minus 57.67 is negative 56.67 divided by negative 0.5. So S sub 10 is approximately equal to negative 56,670 over negative 0.5. So S sub 10 is approximately equal to 113,340. That means Tony's savings after 10 months is approximately 113,340 pesos. Now, if you have any questions, you can contact me.
Now it's your turn. Answer the activity and what to do to practice your